Hi, everybody, and welcome to my session. I'm going to talk to you today on the work that we've done at APAS with event sourcing CQRS, and the talk is about a system with thousands of event types. So I'm a bit sorry for the delay. We're on my mobile phone network connection right now, so I hope it will hold during the session. Let's see if my mouse clicker works. And here we go. Oh, I see that my PowerPoint has decided to not work. Let me start that over. Yes, here it is. Okay, so my name is Michiel Overeem, but I'm already introduced. This is the ways that you can contact me if you have any questions. Just let me know to Twitter or email. So a little bit about our company. I work at AVA Software. We are a Dutch ERP vendor with around 500 employees. We have 4 locations, but our headquarters are in Leusden, which is in the Netherlands. We have 12,000 customers, companies using our software today, mainly in the Netherlands, but also in Belgium and on the Caribbean. So our main software product that we sell is AVAS Profit. We've been doing this for 25 years, and currently it consists of 3 modules. We have a Windows application, which is the foundational module of the whole application, which talks to Microsoft SQL database. We have Inside Outside, which is the intranet and outranet CMS environment. And we have Pocket, which is our mobile app, with which you can do small tasks like timekeeping and looking up contacts. So as I've told, AVAS Profit is our main product. We've been doing that for 25 years. But around 10 years ago, we started a new development, and we started a new platform development, which was called at the time Next, and then it was called Focus, but it was released last year as Small Business Plus. And what we decided to do is to start over with our ERP platform instead of reworking or updating the current product. Why, I will tell you that in a bit, but just keep in mind that we started out developing a whole new platform, and we released the platform with a subset of the functionality. So we've released AVAS Small Business Plus, which you can imagine is focused on small businesses. So it focuses on the bookkeeping for small businesses. It isn't a full ERP suite, but the platform is built in such a way that we can expand it until it can handle everything that Profit can do. So why did we start over? Well, in the past, AVAS Profit was developed as an on-premise application. So our consultants, our salespeople, would go with a floppy disk, later on with a CD or a DVD to our customers and install it locally, and then they can do their whole company automation. However, in the last years, we've moved to a fully cloud-hosted environment. So Profit is no longer on-premise, but you can only host it in our data centers. But the architecture wasn't really used for this, wasn't really developed for this cloud hosting. So there are a couple of things that aren't really cloud native, so to speak. And on the other hand, AVAS Profit was never fully web-based. So it's a large component, which is still a Windows application, but nowadays people want to have a web-only application. So those are the drivers to start something new. Well, of course, we could have taken the current architecture and rebuild it, but we wanted to start over, take things completely different. And why? Because there was another thing that we wanted to accomplish, and that was the separation of technology and functionality. So as you can imagine, in 25 years of development, there is a lot of business knowledge hidden in the source code of AVAS Profit. Some is legacy, some is still very crucial to what we do. But this business logic hidden in the source code makes it not accessible for our business people, for the designers, for our consultants, and so on. And so what we decided to do is to see if we can separate the functionality from the technology in our product. And that's something that we've done with the new platform, which hosts the Small Business Plus offering. So how did we decide to do that? Well, we decided to go with model-driven, or nowadays low-code, as an approach. So when we started 10 years ago, low-code wasn't a term. It's relatively new. So back then we called it model-driven. Nowadays we call it a low-code platform. So we decided to develop our own low-code platform. And what we've done is we've developed our own model. We call it an ontological enterprise model. And the model captures all our domain knowledge. So it's a fully functional model. We don't want to specify technology in this model. This allows us to abstract away all technology and make different choices for different platforms, for instance, or change the technology. Our model is only targeted at ERP, the domain of ERP. So it's not a general model in which you can model all kinds of business applications. We're not the next Mendix or OutSystems. We don't try to be. Our platform is really for our internal software development. We also only want to capture the variability in the model. Because we know we target only ERP, there are a couple of things that we don't have to specify in the model. Things like, for instance, a trial balance, which is common in bookkeeping. We know that there is a balance that needs to be updated and shown to the user. We don't have to model that balance because we know that it is present in the application, and we can develop it through traditional means. So the end result is a combination of both model-driven and traditionally developed software. And finally, the model contains 25 years of knowledge. So here in the left, you can see a small piece of the model. And here you can see that the model consists mainly of 3 types. We have entities, the green ones, and those are things that exist in the real world, like a person, an organization, a product, and so on. In the yellow, you can see the business activities, and those model the processes. So like an invoice or a delivery, things that move through a certain phases and have a current state. And then finally, the blue in the middle, the role, that's the glue between the entity and the business activity. So an entity plays a certain role in a business activity, such as a person or an organization plays the role of customer in an invoice. And this allows us to model a number of things. So these are the basic 3 types. Of course, there are a number of details and characteristics of the types. They come in different forms, but this is the basic. And with this model, as you can see, we have currently 22 entities, 25 roles, and 96 business activities. So here you can see already where the focus of the modeling is, and that's in the processes that automate the bookkeeping of a company. And with this model, we are generating the ERP software. So, like I said, the model is currently focused on small business bookkeeping. We don't have HRM or payrolling yet, but the platform is capable of expanding towards those functionalities. So how does this main development process look like? We start out with a team of business people. Those are people that know our business. They work at AFAS for many years. They know our customers. They can use our internally developed studio environment to model the domain of bookkeeping. From the studio, we export this model, which is just a file that we can read. And then we have a suite of generators that generate the end application. And all these different generators target a specific pattern in the model. So we have, for instance, a generator that targets the entity. We have a generator that targets the business activity. but we also have generators that target a specific combination of a role and an entity and generate something in the application for it. And as you can see on the right outcomes, the application binary, we call it an application package, but basically it's the binary that we deploy on our hosting environment. This application package contains all functionality that's dependent on the model. Like I said, we also have a part that's developed more traditionally. That's a separate package, and those two combined form the whole of the Small Business Plus product. So for our architecture, we decided to use CQRS and event sourcing. Why? Well, the old or current offering Profit has a traditional architecture of a Windows application with a Microsoft SQL database. And the Microsoft SQL database schema currently has thousands of tables, hundreds of thousands of columns, and there are a lot of challenges around locking and blocking in Profit. And we were looking for a pattern that would solve this for us, but also would allow us to scale the application and to make it more cloud native. 10 years ago, we stumbled upon CQRS and event sourcing, and we decided to give that a try. And from there, we grew our own CQRS and event sourcing platform. As you can see, we started out with simple command CQRS. You have a command, it's accepted by an aggregate. The aggregate writes events. It also uses the events for its own state, so it's fully event sourced. The events are also read by a projector, the event stream. The projector creates a query model object or a view of this data, and the query uses that view to present information to the user. So this is the basic pattern that we use. Later on in the presentation, I will go into some detailed patterns that we've added upon to this architecture, but for now, this is the basic. And of course, we have many aggregates, with every aggregate type having its own stream and multiple projectors with their own query model objects. But that seems obvious. So to give you an idea of the size of this application, I have some numbers. These numbers tell you about the types, not on the instances, not on the data that we have of our current customers, but they are about the size of the application binary, so to say. So currently we have almost 4,000 command types. We have 1,300 aggregate types. We have 11,000 event types, 1,000 projector types. We have 5,000 query model objects, so to say. And this size shows two things. So first of all, it shows the size of the application that we are creating. So we are targeting the ERP domain, and we know from experience that there's a lot of functionality in the ERP domain. So it results in a large application. So we're not really scared by these numbers. On the other hand, it also shows that it's hard to generate an application that is targeted to what you really need. So because of the modeling and the generator, you deal with a lot of generic transformations, generic abstractions, and that results in probably too many event types, too many aggregate types, too many command types. I will show you later on from the statistics how we can see that, but it is something that we fight every day by looking at how can we make the generator more specific to generate a more targeted application binary. But this gives you an idea on the size that we're dealing with. So because of this size, we also created our own tools around the application package. So for instance, what you see here is a screenshot of our analyzer tool, and the analyzer tool can take an application package and what we call a host package to together form the resulting ERP application, and they can show a graph of the commands, of the aggregate routes, of the projectors, and all the events. And this allows us to visualize what the resulting application is and to reason about it and look at weaker parts of the current offering. One of the things to also keep in mind, because it seems rather odd to visualize your own application because it becomes so large after the fact. But for us as developers, it's not always clear what the resulting application will be. We have a team of modelers, as we call them, who create new model instances, who expand the model, and then press a button, generate and generate a resulting application that will be deployed to our customers. Well, those modelers have no idea about CQRS and event sourcing because our model is functional. They only are dealing with entities, roles, and business activities. So they don't know what the real impact is of their model on the application. On the other hand, we not, as developers, are not always aware of what they're doing in the model, how big it is, how much new model elements they are adding. And so it's hard to, or it's a challenge to deal with the impact. And this is one of the tools that helps us. So to give you some statistics from production, we have currently 34 million events across different databases because we have separation of database per customer. We have currently 91 customers. We started out with 8. Currently, we are at 91. Those together have 35 million events almost. But those events are from 3,000 event types, well over 3,000 event types. But a few slides ago, I showed you that we have 11,000 event types. So 70% of those event types is not used currently. And that's something that we need to review, analyze, and see what we can do to make our application package smaller, to be more lightweight and less resource consuming. This is this number is overall, so this is from the almost past 2 years, and you can see in the graph how it grows per month. So the bars are per month, but the 34 million is accumulated over the past 2 years, and the bar is the totals in that month. So it's not per month was added, but the totals accumulated until that month, to give you an idea of the growth. And here you can see the full pipeline from model to the generators to an application package. On the top, you can see the host package that I already explained with traditional developed components, and together those are deployed in our cloud. And currently, our challenge is a change in the model, or a change in the generators, or a change in the traditionally developed parts have impact on the running application. So somewhere in those 3 components, a change happens. Could be new functionality, could be a bug fix, could be anything, but it will impact the running applications. And we have to think about what will happen with existing data, what will happen with existing running processes, and how can we upgrade to the new version. And like I said, this is spread out over different teams, different people, not always communicating or knowing that they need to communicate something. And this is the challenge of our development process currently. So to show you how we deal with that, the analyzer that I showed you earlier that can produce the graph is also capable of producing a diff. And in this case, I'm showing you a diff between 2 versions. So for instance, we have a version 1.1 of the Small Business Plus offering, and we have a version 1.2. And what we can do inside the analyzer is calculate the graph and show the differences between these 2 versions. And here you can see command event, the different types, what's added, what's deleted, what's changed, and how much percentage that is of the original version. And this will give us an idea of the changes that happen between 2 versions. And if we in the tool can zoom in and we can drill down to the bottom of a certain event type to see what the changes are. So if you look at the impact of changes, then the important impact is event changes and the query model object changes. Why? Well, a new event is not really impact on the running system because it's a new event that didn't exist before. It's something that we are capable of right now, but we don't have that type yet, so we can just upgrade. An event removal is already a bit not challenging, but something that we have to look into, because it means that an event that we had in the past is no longer present. So the events that we have of that type are non-existing, non-readable, because it's not in our application package anymore. So we need to see if we need to remove events, for instance, or that we need to check if we didn't remove any essential data for customers. So we need to handle that. And then finally, the event changes, of course, show us there where we, for instance, remove property or change the property type. And we need to explore those changes to see if we need any specific upgrade processes to handle those changes. The same holds for the query model objects. Those are our query views. And of course, a new query view is no problem. The removal of a query view probably also isn't a problem, but the change is something that we need to be aware of, because it means that our existing query view probably needs to be replayed or refreshed. And this is the tool that we can use to handle that. So we also created our own upgrade process to handle those changes, which I will show you. So we start out with an organization using our book or keeping their books in our product in version 1.1. So there is a deployment of that version, there is an event store, and there are query reviews, and the company can use their the application to do their bookkeeping. When a new version comes out, we deploy the new version with an empty database in an empty slot. What we will then start to do is do some migration of the data. I will dive into that later, what this migration entails, but it could be a simple copy. And when we're done copying, we can set the current application, the current version, in read-only modus. This will give us the chance to make sure that we have all the data in the older version. So we do catch up and we can make sure that we didn't miss anything. The data is still available to the company, but it's in read-only modus. And when we are sure that we have every piece of data, we can move the current slot to the new version and open up the application again for the company. And we can remove the older version database, or we can keep it for any rollbacks that might seem necessary. And this allows us to do an almost near zero downtime deployment of a new version while the application still remains available to the company. So of course, this arrow of the data migration, this is where the magic happens. And this is where we can do stuff to handle those changes in the application package that I've shown you earlier. And there are three ways of which we can handle these changes. So first of all, we do event rewrites. I have a talk later on this evening about research that we did in updating and event store evolution. There are different patterns in handling event changes. You can do upcasters or weak serialization. We decided to do event rewrites, and the main reason to do event writes for us is that we don't have the history of older model versions. So our application package with all the code, the binaries, are generated from the current version of a model. And we have no idea how the event looked in an older version. So it's really hard to do an upcaster, for instance, in that kind of pipeline. And so what we decided to do is to do event rewrites. And from the diff that I showed you earlier on, we can generate the transformations of the event that we need to do. And so this makes sure that all our events in the event store adhere to the new schema. So this is one way of upgrading that we use, event rewrites. However, we also do repair upgrade scripts. And those repair upgrade scripts are simply specific aggregates that receive a command, can do a query to see what kind of data is in the store, and dispatch new commands to change that data. So for instance, if we add new properties that are have default values or are mandatory, we can issue a command, queries the current view to see if there are instances that do not have this default value or do not adhere to the new schema, and they can issue a command that updates those instances. Of course, we are dependent here on the fact that the query view should be up to date. Well, because we are in this intermittent time window in which there is no new data arriving, we know that our query view is up to date, and we can lever that fact. And finally, one of the other patterns that we use is we can insert default data. So in our ERP system, we deliver what we call templating data to our customers so that they don't start with an administration that's completely empty and they have to do all this configuration. And we give them a default configuration in how we think that they should do their bookkeeping. And in such an upgrade, we can add new default data for parts that are new functionality that is new. So those are the three patterns that we use. So this is in a short window how we do and manage our application, the life cycle, and the size of the application. Well, as you can imagine, we've also dealt with some requirements that forced us to add new patterns to the simple CQRS that I showed you earlier on. And there are a number of things that I want to show you just in a short overview. So first of all, we have process managers. Well, if you've watched the talk of Chris before this talk, he explained process managers, and that's something that we use. So in the middle, you can see the process manager. It can read off events from different aggregates, and we have a combination in which the process manager can issue new commands. It can even receive commands, and it can issue new events. So the process manager is event sourced. So the events that he issues are also the events that he uses to rebuild his state, but it's something in the middle to manage certain processes. Then we also have stream projectors, which are a little bit more off. So we have projectors, of course, that read off events and they can produce query model objects, but we have also projectors that create new events. And you can view them as a single instance process manager. So we can read off events and process new events. But instead of being event sourced, these stream projectors use their query model objects to maintain their state and build up new events. And this is something that we use in places where a process manager with event source state would have too big of a state to process new events. Then we have cross-projector joins. So when we started out, we've taken up the approach that every query can only target query model objects of a single projector because those are consistent with each other. And a different projector with different query model objects might be somewhere else in processing events, might even be halted because of an event that he cannot process. So there's no saying in the consistency between those two projectors. However, we have a number of data objects that are very big, for instance, journal entries in a bookkeeping system. And for those objects, we decided to allow what we call cross-projector joins. So a query can access two different query model objects of different projectors and combine the data. However, we can only use this to present something in the UI. So we do not use these things to make decisions because of the inconsistency, but we use them to present to the user there where it's possible and not a big deal when it's inconsistent. Then we have what we call direct command results. And these two following patterns are patterns that we use to handle eventually consistency. So as you can imagine, when you come from a traditional developed application and you start over and you do CQRS and event sourcing, you bump into eventually consistency and you have to explain that to your users. Now you've just sent a command, but when you do F5, the query is not yet processed, so you get your raw data back. And in those places where we cannot really hide it or cannot work around it, we've added two patterns that we use. And the first one is direct command results. So traditionally, a command can only return OK or an error. However, in our case, we've added the option to return values from the event that he processed. So the command is accepted by the aggregate. The aggregate raises events, and those events can be used to return values directly back to the client. And we use this in certain cases to, for instance, return a unique number that we've calculated. And then we have push notifications from projectors. And these are the main things that we use in the UI. We connect them to WebSockets, and part of the UI then can subscribe to a WebSocket, say I'm interested in this piece of the data, can send commands, or when some other client, of course, sends the commands. And with the projector, when it handles an event, it not only writes to the query model object, but it also notifies the WebSocket that data is changed. And then the UI can query for the new data. And this is something that we use to create a live feeling in the application. Then we also added projectors on projectors. And those are the pieces in the application where we want to kind of mingle the query model object without processing all of the source events. So again, a journal entry is a good example. The top projector will handle events of new journal entries that are created. It will create a view of all the journal entries because you need it, of course, in the bookkeeping system. We have queries using those views, but we have a different projector that in certain intervals creates an aggregate view on the journal entries. For instance, for a ledger account to see what the balance is. And those projectors don't handle events, but are triggered by timers. For instance, every 5 minutes or every 10 minutes or every 15 minutes, whatever. And the projector then can query another query model view, create an aggregate view of all the data, and writes to his own view. And of course, you can optimize there with timestamps or version numbers to see that you can only handle the new data. Those are different subpatterns. And then something more in the event processing space that we've added to our framework is the handling of parallel events and low priority events. So first of all, parallel events. Here in the middle, you can see an event handler that handles or listens to events and passes them on to a process manager to handle them. However, the process manager have different instances. So there can be multiple instances of a certain process running. The events that the event handler handles might be for different instances. And what we can do in our framework is handle those in parallel. So when events are for different process managers, we do a look ahead of the event stream and pass the events to different process managers. So that's one way to speed up the event processing. On the other hand, what we've also created is that for bulk import, as you can imagine, when a new customer onboards, they import from an export from their old system a lot of history, their old invoices and other state that's in the system, and they do a bulk import. But we don't want the bulk import to hinder the current working of the application. So for instance, when marketing comes with a whole new set of mailing list subscribers and they want to ingest that in the system, you don't want that the one client that's writing a new contact into the system is hindered by this bulk import, because it can, of course, it can really create a bottleneck in event processing. And so those events that are raised from the bulk import are marked as low priority, and other events are processed with more priority. So the bulk import, of course, will suffer from this, will be a bit slower, but the normal working of the system will go on. And that's something that we're currently working on. And then the final pattern that's interesting is something that we call sync events. And you can view them as state propagation events. And let me explain that in a bit. So, like I explained, our system is generated from the model by different generators. We have a whole suite of generators. And if you look at the application, you can draw boundaries around the parts of the application that correspond with the output of different generators. So in this case, you can see the output of 7 different generators. So there's a large piece of invoicing that comes from one generator. There's a part of customer organization that comes from another generator, and so on. However, the internals of those parts are knowledge of those generators only. And you don't want to expose that internal knowledge to the different generators. And so what we've decided to do is that those larger pieces of the application can publish synchronized events to other parts instead of publishing their own internal domain events. And those synchronized events contain the data of a certain instance up until that point. So they're really combined state propagation events, which can be used to propagate state to a different part of the system. Now, the fun thing is that those synchronized events are complete every time that they are raised. And so we can remove all the older sync events of an instance. And that's something that we do on upgrade. We go over all the streams that contain sync events, and we throw away the older version. So that's something that we do to automatically clean up. But the state propagation events help us in maintaining boundaries between the different parts of the application. So in hindsight, I've shown you different things, how we handle the development of the system. I've shown you how we use low-code to develop our own platform to include business people in the process of software development, to give them the tools to develop the application, but also to separate technology from functionality. I've shown you how we use a custom analyzer to do impact analysis, how we can do different calculations between two versions to generate automatically event rewrite transformations. I've shown you how we do a blue-green deployment for the upgrade process, in which we can apply event rewrite and repair scripts. And I've shown you several specific patterns in CQRS and event sourcing in our architecture to handle more complex requirements. So, and with that, I want to thank you for your attention. Again, you can contact me on these addresses. You can find me in Hopin and in the Miro board. And later on this day, tonight, I am giving you a small talk on a scientific study that we did on event sourcing of 15 minutes. So come see that if you want to learn more of how we did a scientific study on different engineers using event sourcing.